Hello students, welcome to Talk on Civil Engineering. Let us try to find out equation for the kernel of circular section, or we can call it as core of circular section. The core or kernel of a section is nothing but usually in a column sections, when the load is provided with some eccentricity, you will get the direct and bending stress. Okay, so in that case, you may get some chances of getting a uh, tensile stresses in the section. Okay, and we all know that column, usually if you talk about the concrete columns, the concrete is good in compression, but it is weak in tension. Okay, so this kernel or core of section is nothing but the section in which the tensile stresses are zero. Okay, so at that section within the particular section, you won't get any tensile stresses. Okay, so it will be completely in compression itself. Okay, so that part of section is called as kernel or core. Okay, so there will be no tension stress, that is tensile stress, or the minimum stresses is zero. So usually if you talk about the stresses in compression members, you will get the direct stress and bending stress. Okay, so the combined stress will be of the direct stress plus or minus the bending stress. Okay, so the maximum, usually the maximum stress, that is sigma max, is sigma d plus sigma b. So this will be, obviously this will be in compression itself, so there is nothing to worry about this. And sigma minimum, usually it will be in tensile. Usually it will be in tensile, or sometimes it will become compression also. That means if you get a positive value or greater than zero value, so it will be in compression. And if you are getting the value less than zero, it will be in tension. Okay, and we have to see that the sigma minimum value, that whichever you are getting the sigma minimum value, it should be greater than or equal to zero, because if it is less than or equal to zero, if it is less than zero, it is tensile. If it is zero, that is okay, there is no tension. But if it is less than zero, it is a tensile. So we'll get as tensile stress. Okay, so we'll be using this expression to find out what is the kernel section or core of a circular section. Okay, so let us use this equation. So we know what is sigma minimum. Sigma minimum is equal to sigma d minus sigma b. Okay, and it should be greater than or equal to zero. And sigma d is nothing but the direct stress, that is P by area. Okay, minus, and sigma b we can write it as moment into E. So sorry, P into E is a moment. Okay, P into E is a moment. So here M is equal to P into E is a moment. Okay, divided by Z, you will get the stress. This is the bending stress. Okay, so it should be greater than or equal to zero. Okay, and Z we can write it as, so P by A, Z we can write it as 5 by 30, pi d cube by 32. So pi d cube by 32 is the section modulus for a circular section. Okay, so d is the diameter for that. Okay, and we can rearrange this equation something like this: P by A minus PE by, so we can write this 32 has PD square into D by 4 times into 8. So 4 8 is 32. So we can write like this, and here we can take P by A. So this pi d square by 4 is nothing but area, right? So we can take P by A as common. So it will be 1 minus 8 E by D, right? So I have taken A to the numerator place. So it should be greater than or equal to 0. So this value should be greater than or equal to 0. Okay, and to further simplify, if I take p by a to that side, it will become 0. So simply I can rewrite this equation as 1 minus 8e by d should be greater than or equal to 0. So let me change my pen. So let me take this 8e by d to that side. So it will become 1 should be greater than or equal to 8e by d. Okay. So now I will take 8 by d to that side. So it will become d by 8 should be greater than or equal to e, or else I can rewrite this equation as e should be less than or equal to d by 8. So this is the e eccentricity within which there will be no tensile stresses. Okay, or else in other way, the eccentricity of loading. So E is nothing but the eccentricity of loading, right? So if you apply the load within this region, that is d by 8, so there will be no tensile stresses. So if you apply the load within this region, that is 10 by 8, so there will be no tensile stresses. So here you can see this is the, let this be the section where it is d by 8. So d by that d by 8. So if you apply the loading within this region, so there will be no tensile stresses. That's what it means. Okay. So this is how we can derive the expression for kernel of circular section. So we got equation has d should be less than or equal to e should be less than or equal to d by 8. Thank you all.